Um, Types is one of those things. Like there are a few concepts I think that we'll come across that are like they're things that kind of make sense if you don't think about it too hard, and then once you do, it starts kind of breaking down very quickly. Um, so I think I think everyone in this room at this point is probably somewhat comfortable and knowledgeable with types, right? Like a string or a number or a boolean. But there are some kind of weird edge cases slash properties of them, and we'll cover them, at a higher level here. But really, a lot of it are things that as you kind of code more and more in JavaScript, you actually start to get a very good feel for how certain things behave or are expected to behave. Um, so you will come across a lot of details on this page. I wouldn't like one thing I want to caution against is like this is by no means meant to be like a memorization exercise. Like the goal is not for you to necessarily memorize every single condition, but at least like have a good sense of like if you ever do come across an error where you're coding and you're like, hey, this makes no sense. I thought this type had this kind of issue. If you're to Google that error, like I guarantee you, it will be the first several results are going to be a bunch of people who had the same questions that you did, right? So don't treat this like a memorization exercise, but more think about it as like if I was to use this, how would I use it? And you'll eventually get a really good intuitive understanding of how types work. So there's like a more kind of worthy very kind of verbose explanation for what a type is. But essentially, I think that last maybe five or eight or nine words really say well, right? It's just that it distinguishes one kind of value from another kind of value to both other people, other humans who read your code, as well as your computer who actually has to, or as well as your JavaScript engine who actually has to compile and execute that code. Um, so this is just meant to be a primer. Just take a look at it, but don't stress out if it doesn't make sense just quite yet. So types in JavaScript are divided into two types, right? There's primitive and there's object, or also called non-primitive types. Primitive are these types up here, and it's actually very important that internally you just have a sense for like these primitive types, and these are very very important. So looking at at a very high level, like what do you think separates a primitive type from a non-primitive type or an object type? Sure. So string, numbers, booleans, undefined, and nulls are primitive types, and then these five types here, object array, dates, regex, and functions, are non-primitive type or object types. Just looking at a high level, what do you think is the difference between these two types of types, or these two types of JavaScript variable types? Yes. Okay. Yeah. That's yeah. Very good. Yeah, that is true, but not necessarily. You can also feed arrays into other arrays, right? You can have an array of arrays. So you can nest different objects together. So yes, primitives can definitely go into objects, but I think you're kind of teasing at, and I'm sorry, Alex. Like when you said like this was coded into JavaScript, what the way that that engineers think about this is primitives are data types that you cannot change. Okay, so like that's really like the main distinction here. Um, One like kind of key under the hood nuance here is that even though we call an array we call it date and date, at the end of the day, they're all like from a very technical implementation standpoint, they're all objects, which is why we call them object types. But for now, at least at a higher level, just know that primitives are values that you cannot change. These ones you can change, right? Two will always be two. You can never in JavaScript say two is something else. You can make an array, you can add values, you can take away values, you can make it longer, you can make it shorter. With an object, you can definitely add more keys, you can remove properties, you can change values. You can do all of that with objects. You can't do it with primitives. And we're going to talk a little bit more about why that is. So let's start with the first primitive, right, which is numbers. Numbers, not too much to talk about here. Negative, fractions, decimals, JavaScript is very, very friendly in that regard. You can give it a decimal and it's smart enough to recognize as a number. Same with a negative, etc. Um, and we use numbers primarily for basic mathematical functions. These are the ones down here. I mean, you should be very familiar with most of these. The one that maybe you haven't seen before is this one called the remainder or the modulus. And that basically is, if I do like 5 modulus 3, it's basically saying when I divide 5 into 3, what's left over or what's the remainder. Does anybody off the top of your head, or maybe you've done research already, know why modulus, or one very, very, very common use case for modulus?
Check if the number's even.
Yep. Yeah. So one very common use is if a number is even. So if you just take a number and you take the modulus 2 of it, if it's 0, it's even. If it's 1, it's off. Right. So that's just like a really quick shorthand that a lot of people use for modulus. But yeah, hopefully nothing here is groundbreaking for anybody. If it is, we might need to do a lot more review on some of this. Okay, so mutability is just a longer way of saying can you change the value, right? So immutability means we cannot change it. Operations are very important, right? If I have a variable called number and I assign it to the value 12, right? What all of this is just saying is that, look, we can change the variable, but the variable doesn't actually change the number, right? 12 will always be 12. You can say, hey, this number right now is 12, and if you add 2 to it, it'll just say this number now points to a 14, right? But the 12 is still 12, right? Like we never fundamentally take the value 12 and ever modify it. And so that's like at the heart of it, that is the key characteristics of primitive types in JavaScript. Is that yes, you can store the value in a variable somewhere, and you can take that variable and point it at other values, or you can change it, you can reassign it, whatever. But the base number or the base primitive type can never be modified. It's like saying if this value is 5 or if this value is true, you can never make that value something else. You can have the variable, in this case num. Num can very easily point to something else, right? It can now say, hey, I now want to reference the value of 14, but 12 will always be 12. Like that never ever changes. Okay. Does it feel like, I know it might be a little tricky, but does that like at a higher level, like does that kind of like sit well with people when we say like something like a number cannot be changed? Okay. Oh, you're gonna find out very shortly anyway. Booleans, even simpler, 2 values, true or false. Let's see what, oh yeah, so obviously you cannot name anything true or false. JavaScript will scream at you, probably throw in an error or something if you, oh, yeah, there you go, if you do that. But, use Booleans appropriately, right? If you have something that can only take one of 2 conditions, use it. Otherwise, don't. There are some cases where people try to like say, well, I can use, if I have 3 possible values, I'm gonna use a Boolean. No, just Boolean should only be reserved in very, very binary cases. No. So now we're getting to some of the ones that you probably see, but maybe are not things that you would use as often, right? So a null value is something that a null value is something that it means there's no valid value currently, but it's kind of it's intentionally null. And I'll just kind of lump this in with undefined, which I think to most humans at least, like those things, oh well, they both mean that there's no value. The difference is if I just do something like var middle name and I never give it a value, what this tells JavaScript is, hey, I've tried to declare a variable, but I haven't given it a value yet. Therefore, it's undefined, right? As in, like I've acknowledged this variable exists, I haven't tried to give it a value yet, so therefore it's undefined, right? Sorry, undefined is because we haven't set it yet, but null means I've tried to give it a value and there wasn't a valid one, or I tried to do an operation and a null came back, or something wasn't valid for it, or I might even intentionally say, hey, this is not a valid thing, like we did in the previous slide. We can even explicitly say, hey, var middle name is equal to a null value. You'll see them interchangeably, and really, in my like in my experience, like you actually the nuance there is actually more valuable when you're trying to figure out an error, because when the error log says something is null, it usually means something very different than if something is undefined, and that usually helps me kind of figure out like at what point of my code base am I like not following through logically. But that's just kind of the distinction here. And once again, null and undefined, they're primitive types. You cannot change them. And then this is the one that I think most people struggle with the most, a string. I think conceptually most people think, well, a string is just a collection of letters, right? I should be able to add things to the string. I should be able to take things away from the string. But in JavaScript, you can't do that. In JavaScript, a string is immutable. It's a primitive. And so, we define a string by doing single or double quotes. There's basically not a huge difference between the two. I think in general, people say always use one single quote unless you have to use two double quotes. And the only reason why you need to use two double quotes is because you have a single quote in the string. But for now, just for the most part, you can go with either or. But I personally use single quotes. I think it's a little bit cleaner. So strings, you guys have a good sense of how to define strings. But where the immutability property of strings really come through is when you try to do any operations with strings, right? So so you might see people use strings with this plus sign. And what that means is it looks like the mathematical operation for addition, but it's really something called concatenation in programming, especially with strings. What it does is you're not necessarily adding it, but you're just kind of smashing it together and creating a longer thing. And the other really interesting here is that first name in this case is Amy, last name is Smith, right? We concatenate it and we store the value under full name. But notice, we're never changing Amy, or we're not changing Smith, right? These values are inherent. Basically, for any primitive, what it means is you can do an assignment all you want, but you can never ever change what's on the right-hand side of the equation. Okay? The right-hand side of the equation is once you declare it, it's permanent. It's always like that, right? But and we'll talk when we move on to the object types. You'll see why that's not the case for those types. But yeah, so concatenation is a way to add to kind of put strings together, and then you can also access the letters of the string using something called bracket notation, which you might have seen already if you've done a little bit of work with arrays. But really, you just give it a number. That number is the index. In JavaScript, all indexes start at 0. So the first character is at index 0, and you work your way up. So the most index could be is the length of the string minus 1, right? Because you're offsetting everything kind of 1 to the left. And so this is just some other ways you can do to access or to perform some operations with strings. And then lastly, just dot length is one that you'll see quite often too. I think we actually saw it earlier today, where if you want to go through every letter in a word, you would iterate over this dot length, right? It just kind of gives you how many characters there are in the string. And then just some more, like I said, don't bother writing these down. You'll have these slides. You can check them if you want. But here are just some things that JavaScript says. Hey, I think people use this pretty often. Let's just build some built-in ways to make their lives a lot easier. So if you want to capitalize everything, if you want to lowercase everything, if you want to split it up based on different delimiters, etc. And there's a lot more than what's listed here. People use strings a lot, so as you can probably imagine, the guys who or the people who kind of written JavaScript, they do try to make it easier for more commonly performed operations. Okay, let me see changes. Okay, cool. All right, let's go through type of, and then I'll pause for questions. Type of is actually a really nifty thing. It's also a reserved word in JavaScript. Reserved just means you can't use it for a variable name. You can't use it for anything else, right? Like JavaScript will hold that word very closely to the chest. And if you do type of, it will actually just tell you exactly what type of thing it is. And it is super valuable, especially when you're debugging something. Is you can just drop type ofs everywhere, and it will just tell you, hey, like, what am I? What is this variable? What is its current state? The reason why type of is super valuable is because as you write longer and longer code, especially in today's workshop, you'll see how certain variable types can change over time, right? Like a variable may initially be a number, then it might become a string, then it might become a boolean, then it might go back to an object, right? And you want to be able to, at any point, like point at it and say, okay, what are you right now? And that will tell you where in the code that particular thing is. And the only downside of this is that it's very, very ambiguous for anything that's non-primitive, because once again, under the hood, JavaScript implements all non-primitive types as objects. Okay. Any questions so far? Hopefully that was a review for most people. These are kind of like very foundational aspects of JavaScript types. And then this guy down here. This was actually I want to say like this was actually like an implementation flaw in JavaScript. But then people just kind of kept using it, and then when they realized they had to go change it, they didn't want to change it because a lot of people wrote code assuming this was true already, so they just kind of kept it as is. So this is like one of the known things where it's like they made a mistake, but then people started using the mistake, and they couldn't really get pull it back anymore. So for better or worse, that might be the only kind of special edge case there, where it's technically a primitive, but JavaScript treats it as an object. Okay, coercion. Coercion now is when we talk about changing data types, either from one primitive to another primitive, or from primitives to non-primitives, or vice versa. So these are all 6 types that JavaScript supports. Every single thing you see in JavaScript will be one of these 6. It's really not possible for it to not be in that list. But we'll see something like this, right? Like in this case, we have my_num, which is a 4, and my_string, which is the number 8, but in text format. So you see here that when we try to add them together, called combine, we actually don't get maybe 12 as maybe some of you would predict. Rather, we get 48, right? So here we see that the operation is less of an addition, but instead, it actually is a concatenation, except we treat the number 4 as a string 4, and we concatenate it with string 8. And we can verify that very, very easily by checking the type of. Once again, notice how my_num is a primitive. You're never going to change that, right? That's always going to, we didn't affect that at all. So that will still be a number, but combined is a string because of the operation that we've done here. Okay, so that's just an example of coercion. And then when we talk about kind of how or why it happens, the reason why coercion is very tricky is because a lot of times there's is this a slide or okay, it might be on the next slide. So I'll talk about it a bit. But so coercion happens primarily in 2 places. There happens when we're trying to do an operation, so we actually explicitly write some code that does this, or you can actually also shove it in something called a test expression. So whenever you do an if statement, you know how you have a parentheses and you try to put something in there, like if this is true or if this is false. One kind of shortcut you can take in JavaScript is actually you should never need to write if this equals true or equals false, because the if expression here is set up so that it takes whatever you give it and it will try its best to make it into a boolean, into a true or a false. And if it can't, then that might throw another kind of error. But that's just something that if you have like a number, for example, and you throw it in there, it will try to convert the number to a boolean, even if you don't explicitly ask it to. And so that's why we put this kind of case up here, is that it's kind of we call it an implicit conversion, right? You don't necessarily tell it to do it, but it will do it automatically, or it will do it kind of under the hood or behind the scenes. That's a question closer to a boolean, yeah. And then you can only coerce to a primitive type. You can never coerce something to an object type. So here, when we look at this, even though we have 2 strings, when we do the operations, this is actually less of a math. This is actually, there's really there is math here. So addition, I think, is the only concatenation for strings. Everything else we'll try to convert to a number first. So in this case, we try to do string 1, which is a string. We try to multiply by 2. JavaScript says, well, you're trying to do multiplication, so I'm assuming you want it to be a number. Let me try making it to a number first, and then which becomes 1, and then you multiply by 2. So now you have a 2 as a number and 2 as a string, and we add them together. The the string concatenation kind of supersedes the number, and that's how we end up with 22. One of the things here that's just, I guess, as a good rule is that okay, I know a lot of this is kind of just a lot of words at this point. So if at any point you have any kind of questions like, oh, what would happen if we did this? Like, feel free to shout them out to me, and like I'm happy to just throw them up here so we can take a look at it. So earlier what I was saying was, let's say we do something like this, right? We do 1 multiplied 2, we get 2, right? This is what we saw in the example. But what if I change this to something like, like an actual word? What will happen now? So undefined, NaN. Any other guesses? This twice, or repeated twice, okay. No return. Okay, so we get NaN. NaN is a very, very special case. It stands for not a number. And because JavaScript sometimes does things that are kind of funky, if we do type of NaN, it's a number type, but it means it's not a number. Essentially, you get that when you try to do mathematical operations on things that inherently don't support math, right? So if you try to multiply a string, in Python, it would repeat it twice, but in JavaScript land, it'll say, hey, this is a string, we don't know it's for numbers, we tried doing this, it didn't work, we're going to give you back as something that's not a number. We can't show you what it is because we don't necessarily support it as explicitly. Okay, so back to this one. Okay, so implicit versus explicit coercion, should be pretty straightforward, right? Explicit means, hey, look, I'm going to tell you, exactly what I want you to become, right? I'm going to say I'm going to create a new string. I'm going to feed it a value, and it should spit out a string to me, or I'll try to convert it into a boolean or a number, etc. Implicit is a little bit more subtle, right? In which, like, if you just add a number to a string, remember we saw earlier, when you add a number to a string, rather than treating it as math, it would treat it as a concatenation method. And so I'll actually try converting both into a string first and then switching them together. So someone will see this and there's zero ambiguity about what you're trying to do, right? Like, clearly you're trying to cast this into a string. This might be a lot more subtle. Someone reading your code at first might not realize that, hey, this person's actually trying to convert this into a string before they do the next thing. So also, as a good rule of thumb is, if you're ever trying to kind of do a coercion, if it's something that like if it's possible, whenever possible, I always like to just do this to make it explicit. So if someone's reading my code, they know very clearly what I'm trying to do, and then I would rather save them the time of trying to figure out, oh, like this also works from a pure coding technical standpoint, but it's also a lot more ambiguous to the reader, especially if you're reading through a lot of code in sequence. So how does coercion work, right? Who decides that when I try to add a string and a number, that the string concatenation overrides the addition? And really, a lot of all the rules around JavaScript in general are set by the ECMAScript specification, which are the same people who define all rules for JavaScript, right? They're the people who set the standards for ES5, ES6, etc. Once again, just don't worry about memorizing all of these for now, because when you start working on them, after a while, you will get a very intuitive feel for operations and which ones are kind of, I would say, more first-class citizens versus second-class citizens, right? Like, once you start adding a lot of strings together, you'll like kind of get a feel that, oh yeah, like strings are first-class citizens relative to numbers when you do an addition operation. There's really a lot of different permutations for how you want to coerce something. But once again, I think coding in this case is probably just the best example. I would rather you write a lot of functions that use coercion as opposed to memorizing a table of coercion of like, I do this with A, I do this with B, I get C. Okay, any questions so far on coercion? Implicit, explicit, anything I've covered so far? Yeah, I mean, you will get stuck on this workshop because there's a lot of things in there that, like, I think as you practice more and more, it'll just become kind of more clear to you. But like, Are there anything fundamental about what I've said that's like unclear? I know it's also right after lunch, so people are probably a little bit like kind of tuning out a little bit. Okay, cool. So truthy and falsy is another quick topic. This one should actually be a lot faster too. But this we just want to this is also kind of I would say an implementation of coercion, except this coerces something to a boolean, right? And booleans by definition have only two values. You're either true or you're false. And how we get there can sometimes be a bit tricky too. So every JavaScript value and expression can be coerced into a boolean. And the reason why that is because when you're trying to do like an if condition, or you're trying to do like certain evaluations, like at some point JavaScript says, okay, it's one or the other, and if it's not this, then by default it's this, right? So it's almost like an if-else statement. You don't really check the else, right? It's just the if that matters. If it's not this, then by default it has to be this. And so because of that, everything eventually can be boiled down to a boolean. But because these are coerced into booleans, like for example, the number 3 is true, right? But it's not actually true because there is a value called true that is explicitly true, right? So instead we call it truthy, right? As in, if we were to take this value and we were to force coerce into a boolean, it's truthy. It's kind of like true. It will eventually become true. And the opposite of that is false, right? If we push it hard enough, then JavaScript will say, hey, this is false. This is not true. And so when you look at all these things here, right? If, while, and I guess for, I'm not sure where that comes from, but especially in the if and the while loop, right? Like if you feed it something, JavaScript will do its best to convert it into a boolean, which is good and bad. It's good in that, like, in most cases, it will kind of push it towards the result. It's bad because if it doesn't push it the right one, you won't know unless you actually examine close the code in more depth, right? And that can be something dangerous, like especially for example in a while loop, where if a while loop by definition needs something to terminate, right? So if you feed it a value that always evolves to true, then that's going to take your computer down because you're going to try running this process and it will never have an ending point. And so with anything implicit, I always do a double check on, just because you never really kind of get a good sense of what goes on until you can trace the code as it runs. The last thing here that we'll talk about is this exclamation point called not. And really that's all it is, right? Like you put that in front of any operation or value, it will just give you the opposite of it, right? So usually I think the process is, if you think about like kind of, if you do like exclamation mark and then an expression, it will convert the expression to a boolean, and then it will just take the opposite of that boolean. So if you convert it to true, then it'll just say, great, this is false, right? Or vice versa. The not can be a little bit tricky to use, especially when you see it in the context of having 2 in a row, because here we're actually no longer converting it, or this actually explicitly converts it into a true or a false, right? Like basically, like let's say I have the number 3, right? If I do exclamation point 3, what does that give me? So sorry, so is 3 true or false?
True.
Okay, so then I do exclamation point 3, what does it give me? Okay, and if I do exclamation point false, what does it give me?
True.
Right. So the reason why that's super important is because if I have 3, but I need it to not be truthy, I need to actually be the value true, then double exclamation point is the best way, is a really good way to do that, right? That basically removes all ambiguity from it, and the output of this will always be a Boolean type of either true or false. There's no more ambiguity there. Yeah.
So if you did that in front of the 3.
Yep. So you're saying if we do something like yeah, that will just give you a true.
Okay, so does it change the like truthy falsiness?
Of what?
The 3. Like if you do.
Right. So a 3 is just a 3, right? I can get the opposite of that really easily. But if I actually want to get like the kind of like a positive like what it is right now,
Mhm.
and I need it in Boolean form, then it'll be the true.
Oh, I see what you're saying.
So if I want to do the opposite of it, then one exclamation does the job. Two exclamation points kind of preserves its truthiness or falsiness, but gives it to you in the exact Boolean type.
Okay.
Right. So if we do type of here, I guess, and also type of here as well. See, now I get Boolean types. Now there's zero ambiguity about what I'm doing. Okay. All right. So here's another thing which you could memorize, or you could just use it enough and burn enough times and spend enough time like struggling with it that eventually you just kind of internalize it. Those values are falsy in JavaScript. The good news is everything else is truthy. So if you have a good grasp of what false is, then you also, by definition, have a good grasp for what true is. Not going to go through these with too much depth. I think intuitively we see a lot of those things and we think, okay, like if I was to, really, put my foot down and say is it true or false, I would probably guess those things are false. But once again, right, these are just things that you kind of eventually learn through doing. Any of those seem unclear to anybody? Yes.
So three strings are
Empty strings, either with one single quote or double quotes. For the most part, single and double quotes don't matter.
The last example.
Not a number.
Oh no, sorry. On the right, console log, we have null in it.
Yeah.
Why is that true?
Why is that true? Oh, okay,
Is it
great
because
one.
it's an array with something?
Yep, exactly.
Okay.
Yeah.
Even though it's null.
Yep. So, oh yes, I was gonna do that. I had to do here. So here, this is what you expect, right? Null is false.
Yeah.
So when we do double exclamation point null, it should give me a false, right? But in this case, this is actually not a double exclamation point of null. This is a double exclamation point of an array with one thing in it, which is true.
And it doesn't waste its time going into the array to look at what's in it. It just says okay, it's an array.
Yes, and
It just
actually.
never gets-
Yeah, and actually, I don't even know if JavaScript goes that far. And I believe all arrays are by default true, so it might just see as an array type and just gives to. So let's.
That's what I was going to ask. Is it
Yeah,
empty array?
I think that's true. Yeah. So all array types are true by default. And, yeah. Okay. Yeah. Cool. So not numbers. Yeah. Okay. Yeah. So then, if it's an object, then by definition it's true. Right? Because if you notice, these six are all primitives. Number, string, no, undefined, false. These are all primitives. So if it's an object, if it's an array, if it's a date, a regex, a function, whatever it is, you don't even check. It's going to be true. The only thing that can be false, and I guess, are primitives. Oh, that helps. Cool. Okay, yeah, and this is just to tell you the shorthand of a lot of times when we do an if statement, you don't really need to do the equals to be a 0 or a 1. Just know that by definition, JavaScript will try to convert that to a Boolean for you. And so if you say, hey, this equals 1 is true, JavaScript kind of makes that assumption on your behalf anyway. And so yeah, but that's just a really quick example of that. Does that make sense, everyone? I'm saying like you don't even do an explicit comparison to 0 or 1 because JavaScript's going to try to do that anyway for you when you're trying to put it in the middle of an if or a while or a test clause. I don't think we can do this together because I think you'll be doing a lot of this in the workshops after the next slide. Okay, this is the last one that I think is actually very important for folks to pay attention to. And we're going to kind of go a roundabout way of explaining why it's important, and then we'll give you like a really, really simple rule of thumb here. So triple equal sign versus two equal signs. Triple equal signs just means, hey, these two values are the same type, and they are equal. Okay, it's as straightforward and as precise as you can possibly make it. Okay, same type, same value. If it's true, or if they're equal, then it's true. Otherwise, then it's false. Very, very strict and explicit. Okay. Double equals. Double equals means, hey, let's try coercing you guys to the same type first, right? So if I have a string 4 and a number 4, it will try to coerce it into, I think, the string type first, and then it'll compare them and say, great, now that I know we're on the same playing ground, are you guys equal, right? Or now that we're both the same type, are we equal? Okay. So 1 and 1 obviously is equal, right? It would be equal with triple as well, right? Because and so obviously by definition it would be still equal if you relax the restrictions. 1 and 2 will never be equal. One number and one string equal. So far makes sense. Empty string equals false. That's true because it both values are false. And then is true equal to 1. That's true as well. Okay. However, it's very, very unclear a lot of times which form it chooses to convert it to, right? So in my previous example of the number string 4 versus a number 4, right? We know that if you convert both to a string or both to a number, it will always both be true. But you don't actually know, you don't see very clearly which one it's doing the comparison to before it does the compare, right? And so the Mozilla Foundation are the folks who do this. There is a chart here of all 36 ways that we compare different things, and it will tell you exactly how it converts the thing A versus thing B before it does the comparison. But if you notice it, it's actually like not random, obviously, but it's actually not very structured, right? Like there's not like a single formula you can do to tell you which one does the conversion. And so before you try to look at that and memorize it too closely, just know that like this, like using two double equal signs is actually very dangerous for that reason, because you actually deep down you actually don't necessarily have a good sense of what the computer is doing. And so for that reason, this is a short summary of this, is that you should almost never use double equal sign in your code. There are very, very strict situations in which you could, but I would say in everything that we're going to do in this bootcamp, and really in most of the things that you'll be working on, unless you're working on a very specific set of stuff, there's never really a good sign to use double equal signs. If you ever do feel like you need to do a conversion first before you do the equality, then you do the explicit conversion yourself. Like if you want to say, hey, I need to make sure these two are equal as numbers, then you say number A equals number 2. Like you do the explicit conversion yourself. Don't trust JavaScript. Don't trust JavaScript to do it. So if you guys are writing or seeing any code with two equal signs, then you know right away that that's, I guess, bad form, we'll say, and we'll probably want to find a different way to present that. I think that's the last slide. Any questions? Okay, cool. So that's kind of our coverage of types and the basic types and their properties. We'll do another pair programming workshop set of problems now. And for this one, I'll probably walk around a little bit more to kind of check up with you to see how things are going, and then we'll do the same thing we did last time. Or at the end, when we do the group review, I'll just ask a few of you to Slack me your solutions, and we'll walk through them together as a group. And then I'll also release the solutions for the last workshop too. Okay, cool. So feel free to take a 1-minute break, but like while you do that, I'll stack out pairs. So just get started whenever you're ready.